Hello, welcome. This is now the third question for Edexcel S1. Now, June 2012. So we're given this table. So when P is 3, T is 1. When P is 8, T is 3. When P is 30, T is 9. When P is 25, T is 10. When P is 15, T is 5. And when P is 12, T is 6. Okay. I have to plot a graph showing this. Now, sorry, I think I plot some values before. Sorry, one sec, because I've the way I've drawn it, I've obviously not been able to give you them. Oh no, doesn't give you any actually so far. So we just have to draw on a couple of points. All right, so what I'm going to do, obviously you have proper axes on yours. And I'll just give you a bit of a heads up because obviously I've done this. Basically, between 0 and 5, there are every five along this p-axis equals 10. So when we've got 5 along here, so I'm just working up p's. Pollutant level P. So when pollutant level is 5, so every 5 pollutant levels there are 10 little squares. So obviously each little square equals a half. Okay, so that obviously helps you working out these. Right, so the first one is 3, 1. So if you go across here, 3, so 0.5, 1, 1.5, 2, 2.5, 3. Obviously you have proper axes, but I'm just going to assume I can do this, and you draw that at 1. So basically you just plot the points, and I can't really help you with that because I don't have the graph. Well, I do, but I don't have a projector yet. And you will end up with something that looks like this, with a bit of a gap in the middle, and then 2 points, and then sort of 2 points that look off. What I do is circle them. It doesn't say you can't, but you could just circle them sort of for show that might be an anomaly, which of course is. Now, part B says, explain why a linear regression model, basically a straight line, would be appropriate to describe the relationship between P and T. Now, it's only worth 1 mark, so it's not a major problem if you don't get it, but it says a linear regression model. Now, because you say, okay, the gradient constant, that kind of dictates they are directly proportional. Because there is a line of constant gradient, this shows that the 2 variables of P and T, so you put pollutant level of thinning of the shell, are directly proportional, therefore we can imply they have a linear relationship. You just really, that's a long-winded way, and trying to sound smart, which obviously didn't work because I never do. Basically just it's got a constant gradient, so therefore, obviously these two are anomalies, you don't really have to mention them. But maybe I've just drawn it wrong, but I think, pretty sure that's the way. So you just talk about the gradient being constant, really, and that shows a linearity, so we can use this linear regression model. Okay? The 2 values we're asked to find next. So we're asked to find, so part C, so 3C, says find the values of SPT and SPP. So I'll put C over here. So we should know SPT. What I do, because, okay, this was originally the x-axis, this was originally the y-axis, so obviously y equals t and x equals p, okay? But obviously you don't have to do that. So instead of, this helps thinking about it when you come to a question that potentially is the next part of the little question, I think, where I actually just talk about the product moment correlation coefficient, so PMCC. We have to do SXY over square root of SXX and SYY. Now obviously you know that because that's P and T, that's going to be X and Y, so you don't really know, you need to know which way around it is, but it's nice to have an understanding. So the X value is the independent, the one that influences it. So because this is the pollution level and thinning of the shell, obviously the thinning of the shell doesn't influence the pollution. The pollution influences the thinning of the shell, so therefore as it influences it, it's the independent variable, so therefore it's X. But because we've got it on this graph, you can say P is X and Y is T. But as I said, that's completely irrelevant because you don't really need to understand that. But whatever. So SPT, so it's the same formula. So EPT, take EP, ET over N. Okay. Work out what EPT is. So it's 3 times 1. Oh, sorry. We're told EPT is 694. Just need to work out what EP and ET is. So EP, 3 plus 8 plus 30 plus 25 plus 15 plus 12. And that gets you a value of 93. So it's 93. And then you work out what ET is. So 1 plus 3 plus 9 plus 5 plus... So basically the sum of the T values. And you get a value of 34. So 694, take 93 times 34 over 6. And that gets you a value of 197. Okay, so that's the SPT. Now the STT is kind of the same as SXX. Sorry, SYY, but so it's the sum of T squared. So sum of Y squared, so it's Y squared plus Y squared plus Y squared. So it's 1 squared plus 3 squared plus 9 squared, etc. So we're told that is 1967. I think we're told that, and that's take the sum of T squared, all squared. So it's 93 squared, still over 6. So that gets us a value as 525.5. Okay, so we've got 2 values there. So that's part C. Part D kind of says what I just said. It says find the equation of the regression line on P. So we don't need to know the product movement correlation coefficient. Sorry about that. I got ahead of myself. I invented a question that wasn't there. If you did that, well done. But you know, wasted your time really. But you know, I'm assuming you have the paper with you anyway. So we're asked to find the equation of the regression line of T and P. So we're told that T is equal to A plus BP. Now what I would do, just for simplicity, because I said X equal to P and Y is equal to T, rewrite this as in the form you would normally see it. So Y equals A plus BX. So okay, so that just gives you, so you can just always relate it. But obviously you need to actually work out what is T equals A plus B. Excuse me, is but as I've mentioned, it's nice to be able to relate it. So how we'd work out obviously you'd work out B first. Now B would normally be SXY over SXX. But we know X is equal to P, so we can replace X's with P and Y's with T. So it's SPT over STT, which is what we've worked out over here. That's why we were asked to work it out in part C, whatever it was. So it's 197 over 525.5, and so that comes to 0.32. Okay, it's 0.317, but you know, you can always come back and do this calculation again, because we're going to need to be able to get an exact figure for that. So don't go rounding it straight away. Always think, okay, well, I've got to keep this, I've got to do this equation again, so just bear that in mind. I mean, it won't make too much of a difference if you don't, you just use 0.32, but I like to be accurate. A would normally be equal to Y bar take BX bar, but as we know, instead of Y we have T, so it's T bar take B, and now instead of X bar we said X was equal to P, so it's B take, so it's T take B P bar. Okay, when I say P bar, it's just the sorry, it's just the mean of P. So you could work out what these individuals are. So it's the sum of T over N. So the sum of T over N. We said the sum of T was 34, and that's over 6. So it's 34 over 6. Take B, which is 0.32. But this is why it's good to keep in your calculator. Take 0.32 times P bar. Now we said sum of P was 93, so it's 93 over 6. Obviously you could work that out to specific value. Then you would get a value for A, which is equal to 0.74 rounded. So we've got our values for A and B. Now it's just a case of rewriting this first equation, subbing in A and B. So it's T is equal to 0.32 plus b 0.7 b between, oh god's sake, I made a mess of this, haven't I? So subbing your numbers, if I could actually do it, so t is equal to 0.74 plus bp, which is 0.32 times p. Okay, so you don't put in what p actually is, because this is just sort of y equals mx plus c in that kind of form. Alright, so instead of, you would normally write x, you write p. So don't try and put a p value in there. Okay, sorry I've kind of been off the radar a little bit in this video. So we have to plot the point, so the mean of p and the mean of t. Okay, so when you work, obviously you've worked out the sum, the t bar, which is and p bar. So p bar is 93 over 6 and t bar is 34 over 6. So if you were to put them in your calculator, 93 over 6 is equal to 15.5 and t bar is equal to 5.6 recurring. So that is the same as writing 15.5 for p and 5.6 recurring, or 5.7 for t. Now, obviously, it's going to be quite hard to plot the second point. Fairly easy to point p, because we said it goes up in 0.5s, so you can look where 15.5 is, draw up from that to get about just under 5.7, which you can hopefully work out. And if you get it right, it becomes somewhere in the middle there. And obviously, you draw you a regression line, which looks... Actually, I've done that better than I did on my actual paper. Okay. So the next question, part F, says the scientist... Oh, sorry, E asked you actually to draw that. So you get 1 mark for working out the point, and then 1 drawing it on. Sorry, yeah. So you get 1 mark drawing it on in the right place, and then another mark for drawing the correct regression line. So basically, when I say correct regression line, I mean same above as below. And as these are not anomalies, you can leave it as that. Okay. The scientist reveals similar studies that find pollutant levels above 16 are likely to result in the death of a chick soon after hatching. Now, obviously, you don't need to know too much about that. You just think, okay, well, it's talking about 16. So you draw up from where 16 is. You draw across to Y. You find the thinness of the shell. So estimate the minimum thinning of the shell that is likely to result in the death of a chick. Okay, so you just look across to the point. You go from 16, look across and read off that value. Alright, sorry about that. I know that wasn't the best video I've ever done, partly because I was off over there trying to keep up the pace of the video, because I don't want to waste too much of your life, but I will go back to the normal in the next video. So that was kind of a mess up of a question, really, but as I said, there's nothing much more we can go through on that question. As I said, S1 is just equations, really. It's just quite like AS physics is. So anyway, that's the answer. Thanks for watching, and I mean, do the usual of put yourself through liking it or subscribing it, or whatever you want to do, just as long as it's not a death comment. I'm not a big fan of those. So anyway, thanks for watching, see you in the next video.